if we could do a top contour survey of the greats of astronomy, where would it start? Starting with people who got it wrong, and then correct each other. Like if we were going to do a fast sprint through these, where would we start?
Well, you'd have to start with Gog or whatever, the first cavemen and women. As I said, 40,000
charting stars on the wall. Of
exactly.
The cave.
We don't know who they are.
Telling their youngsters okay, because those stars are there relative to that ridge or et cetera, days are getting longer, days are getting shorter.
That's right.
Ergo, hunt now. Ergo, collect stuff to hunker down. Maybe even don't reproduce now. Maybe even behavioral restraint.
100%.
Maybe reproduce now.
Yeah.
Yeah.
It's going to be much more optimal time for that. Exactly. So tens of thousands pre-antiquity, you would say. Then I would say fast forward to the maybe Egyptian epoch, 5000 BCE, so to speak, when they had also a very zodiological and astrological conception of these objects. But and yet they would build things, in relation to the positions of stars and constellations.
Sundial emerges.
Sundial, obelisks, things that were used, primitive things. Stonehenge also, I think it's like 20,000 years ago. They believe it's related to some astronomical observations. They're not entirely certain about that.
We have to double click on Stonehenge. How do you think it got there?
It's one of those great mysteries. I think it's less controversial, Stonehenge, than the pyramids. The pyramids seem to be like almost, they lead people into thinking about aliens and all sorts of
what do you think of? Is it? I mean, given their mass, given their location, given what we knew about populations then, and given what we know about the strength of people and the tools they had at the time, is it reasonable to assume that people built these things?
I mean, certainly. I mean, you'd have to convince me that people didn't build them, but exactly how they built it is a great question. I mean, so for example, I mentioned this when I was on Joe Rogan's show. I said, if you measure the bases of the pyramids, it turns out that they're a ratio of a cubit, which is actually cubits, not quantum bits, like you and your dad talked about, but cubits is the length of the pharaoh's forearm. It's basically 1.5 feet, roughly. So back then, if you were like the president, you were also the metric standard for all of civilization.
Wild.
And it makes
sort of like models on Instagram, right? Everyone's trying to attain these. What's the standard?
That's right. Exactly.
What's the standard?
Right. That's right.
Wild. So the pharaoh's
Instagram
forearm
famous.
is this about carrying items?
Well, it was just for length or like a foot. We talk about a foot. It was a pharaoh's foot.
Sure.
Yeah, that's where we get those from, right? So there was only kind of one rough standard for calibration, which is incredibly important for removing systematic effects in science in general. So you had a calibration standard. Now we have like a bar of platinum. We've defined, the second in terms of oscillations of a certain atom called cesium and how many times it oscillates per second.
Sure, a degree, right? Yeah, a calorie, right?
So now we want to define those in terms of physical quantities, not in terms of people. And so doing that has been a great advance forward in science. And we've only recently gotten rid of what are called artifacts. So it used to be there was a rod that was 1 meter long. And the meter was originally defined as 69,000, I forget, of the distance from the North Pole to Paris. But that obviously depends on assuming the Earth is a perfect sphere, which it's not, right?
It's kind of chubby around the middle,
yeah,
right?
That's right. It bulges because it's an oblate spheroid, right? Exactly. And so all these things that were relics, we want to get rid of them and tie them to fundamental properties of, say, a quantum system that's very pure and we can isolate it. We don't want to use a pharaoh's foot either, so we have to come with a length standard. So now we use the speed of light times the second, and we can define things in those terms. But back then, so they didn't know that. But I told Joe, as I said, if you measure the base of all the great pyramids at Giza, they're all multiples of a cubit times so many numbers of the number pi. So but pi wasn't known to them. Pi wasn't known to be irrational until the Greeks and Euclid proved that it was irrational, and that it didn't come from a computational. It couldn't easily be obtained from. It had an infinite number of digits, right? So how did these Egyptians know that? An alien told them no. The way they did it is they laid it out. They used a surveyor's tool. One of the surveyor's tool is a stick with a wheel on it. So the wheel's a circle, so you got so many multiples, they just counted, and that's how. So we confuse a lot of things.
They stumbled into pi.
Exactly, right? They walked all over. So you don't have to always posit supernatural explanations for things. The answer is simply, we don't know. I certainly don't know how Stonehenge was built, nor do I know how the pyramids were built. But it's not, you would have to convince me that it was built by some other means other than people and the tools that were available to them.
Yeah,
and there's a lot of
likewise. I'm not convinced it came from extraterrestrial.
Yeah, so I don't remember
sources.
how we got on this, but
so we were marching through.
Yeah.
So we were marching
that's
through.
Right. Yeah.
So we have our ancient ancestors, and then at what point do we get to Copernicus and Galileo?
Then it was Copernicus who had ideas but couldn't prove them. He had no data to substantiate the Copernican or sun-centered model of the universe, which is also, by the way, almost everything in science is wrong, right? Copernicus is wrong. The sun is not the center of the solar system, right? There's the center of our solar system is inside the sun because the planets orbit around it, and they orbit around an elliptical pattern which has two foci. So he believed that the orbits were all circles. So he's wrong, but he's more right than Aristotle. So that's why science progresses, right? Newton was right about gravity until he was wrong when Einstein proved him wrong, right? So then you come up to, after him, Kepler discovered the laws of the elliptical motion of planets and their patterns that we still use. We discovered an exoplanet. My colleague David Kipping, I want to introduce you to, he's discovered exomoons. These are moons around other planets, some of which are in the habitable zone of their host star, and some of them have sun-like stars and are Earth-sized planets. It's incredible. There could be, as I said, a link between life evolving on Earth due to the moon on our planet. So too, on an exoplanet, it could require an exomoon, which he's discovered or thinks he has. He's actually very cautious and hasn't said it explicitly. So Kepler's laws underpin all those discoveries, even to this day, 400 years later. Then Galileo, immediately afterwards with the telescope, phases of Venus that only occur if the Earth is not the center of the solar system. The rings of Saturn, he had notions about those. He accidentally discovered the planet Neptune. It's amazing. And then he, of course, the moons of Jupiter falsified the notion that the Earth is the center of the solar system because these moons are going around Jupiter, not around the Earth. So that's completely torpedoed the notion of the true nature of the Aristotelian or Ptolemaic Earth-centered cosmology. Then soon after that, astronomers measured things like the speed of light using eclipses of the moons of Jupiter. They measured distances to Saturn. They mapped out the solar system. And then from there, using parallax, you can kind of gauge the triangulation, and using trigonometry, measure the structure of our galaxy. William Herschel and his sister, Caroline Herschel, was the first female astronomer, first female scientist. She was the first person to use the scientific method and become a fellow of the Royal Society in Great Britain. And then later off, after that, we come to the era of the last, the big developments in technology were photographic plates after that, spectrographs, dispersion of light onto photographic material. You could preserve it in memory. You didn't use sketches like Galileo did. And then up until Hubbell, when Hubbell discovered two major things, one was that the Milky Way was a galaxy. It wasn't the entire universe. There were other galaxies, island universes of billions of stars. And then he discovered the expansion of the universe with help from astronomer who doesn't get a lot of attention. A lot of the women in astronomy got really short shrift. People discovered how fusion works in the sun. Women, Gaspachin at Harvard, and then Henrietta Leavitt, who measured this relationship between the size and brightness of objects called Cepheid variables that Hubble then used to make his law that proved that the universe is expanding. And then after that, people like Penzias and Wilson discovering the microwave and radio astronomy, Robert Jansky, all the way up until, my colleagues today, some of whom I've interviewed, Adam Rees and Brian Schmidt and Barry Barish, who wrote the foreword to my second book, detecting gravitational waves, the accelerating expansion of the universe due to dark energy, first Nobel Prize in astronomy in 2011. Followed up 2017, 2017, discovered gravitational waves from inspiraling black holes. There's so many, and there's so many, I've been blessed to know many of them, and I have them as my academic, pedigree.